Hey everyone, and welcome. So when you're starting out in Python, lists are usually your go-to for organizing data, right? But what happens when you need to find something instantly and you don't know its position? Today, we're diving into two super efficient data structures that solve this exact problem: dictionaries and sets.
See, the thing with a list is you have to know an item's position, its index, to find it. But what if your data doesn't really have a natural order, like say a user's profile information? This is the central question that dictionaries and sets are built to answer. They give us much faster and, honestly, more intuitive ways to manage our data. First up, dictionaries. I want you to think of them just like a real-world dictionary. You don't read from the first page to the last to find a word, do you? No! You look up a word, which is our key, to find its definition, the value. And that's exactly what they're for, creating these logical connections right inside your code.
Okay, so here's the most important thing to remember. A dictionary is all about key-value pairs. Every single key has to be unique and immutable, which is just a fancy way of saying it can't be changed, so things like strings or numbers work perfectly. The value, on the other hand, can be absolutely anything you want.
All right, let's jump right into the code. We create a dictionary using these curly braces, and inside, we define our key-value pairs. Now, notice the syntax here. We have the key name, which is a string, then a colon, and then its value, Alice. Each of these pairs is separated by a comma. It's just a really clean, readable way to group related info. So, how do we get data back out? Well, instead of using an index number like 0, we use the key itself inside square brackets. So in this code, mydict.name is basically asking, hey, what's the value associated with the key name? Let's see what happens when we actually run this. And the output is Alice, exactly what we wanted. We didn't need to know where Alice was stored, just the key that points to it. This direct lookup is what makes dictionaries so incredibly fast and powerful.
Adding new information is just as straightforward. Check out the syntax. We reference our dictionary, pop in a new key, in this case occupation, inside square brackets, and then just use the equal sign to assign it a value. Now, if this key already existed, this would just update the value, but since it's brand new, it gets added to our dictionary.
And there you have it. When we print the dictionary now, you can see our original data plus the new occupation:engineer pair tucked right in there. Dictionaries are flexible, they're mutable, and they can grow as your program needs them to.
Okay, a really quick but super important tip. If you use those square brackets to look for a key that doesn't exist, your program is going to crash with something called a key error. A much safer, more robust way to do this is with the .get method. It lets you provide a default value if the key isn't found, which saves your code from breaking unexpectedly.
Now, dictionaries also come with some really handy built-in methods to work with all of their parts at once. You can grab all the keys, or just the values, or all the key-value pairs together. Let's take a look. First, let's say we just want the keys. All we have to do is use the .keys method. This code is basically asking the dictionary to just give us a list of all the labels or keys that it's using. Now, check out the output. It's not a regular list. It's this special view object called dictKeys. And the cool thing about this view is that it's dynamic. That means if you add a new key to the dictionary later on, it'll automatically show up here. Pretty neat, huh? In the same way, if you only care about the values, the actual data, you can use the .values method. This will scoop up all the values from the dictionary for you, no matter what their keys are.
And just like with keys, we get another one of these view objects, this time called dict_values. It's holding all the pieces of information we stored, ready for us to use or loop over in our code.
All right, that covers dictionaries. But what if you don't need all those key-value pairs? What if you just need a simple collection where you can guarantee that every single item is unique? Well, for that, we turn to our second amazing tool, sets. The definition here is really simple, but it's incredibly powerful. A set is a collection, kind of like a list, but with two huge differences. It has no order, and, this is the big one, it absolutely cannot contain any duplicate elements. That uniqueness is its superpower.
Let's see this in action. It's the best way to understand it. Here, we've got a regular list with a bunch of duplicate numbers. To clean this up, we just pass the list to the set constructor. That's it. The magic happens all on its own.
And would you look at that output? The result is a set containing only the unique numbers from our list, 1, 2, 3, 4. All those duplicates? Gone. We didn't have to write any loops or complex logic. This is, hands down, one of the most efficient ways to deduplicate data in Python.
Sets also come supercharged with powerful mathematical operations. Here we have two different sets of friends. Let's say we want to find out who is in both groups. We can use the intersection operator, which is just this little ampersand symbol as you see in the code.
And the output gives us exactly what we asked for, a new set containing just Charlie because he was the only name that appeared in both of our original sets. You can do this for finding all friends combined or friends who are only in one group. It's a fantastic tool for comparing collections.
So we have dictionaries for our key value mappings, and we have sets for ensuring uniqueness. Now for the most important part, knowing when to use which tool for the job. Let's break it down.
This table gives us a really great at-a-glance comparison. The bottom line is this. Dictionaries are all about the relationship between a key and its value. Sets are all about the uniqueness of the items themselves and the mathematical relationships between different collections.
Let's make this really concrete. You would definitely use a dictionary to store a user's profile, where keys like username and email map to that user's specific information. But you'd use a set to track unique visitors to a website, where you just need to store each visitor's ID one time and don't care about duplicates.
You now have two new, really powerful ways to structure your information in Python. So start thinking about the data you deal with every day. What kind of real-world problem are you going to tackle first with a dictionary or a set? This will get you perfectly warmed up for the first activity, where you'll get to build your own.